welcome to my channel. So I'll be starting a new series on the LeetCode problems. I'll be pasting each and every question solutions here. So let's start with our very first video, which is on two sum. So as you can see, they have provided us with the array nums with the integer target, and they expect us to return the indices of the two numbers such that they add up to the value target. Coming to the examples, this is the array 2, 7, 11, and 15. The target is 9, and they expect us to return a set of indexes with sum up to the target, which is 9. So here they mentioned the output as 0 and 1. So if you sum up the 0th index with the first index, which is 2 plus 7, it equals to 9. Now, moving to the second example, 3 to 4, the target is 6. If you sum up 3 plus 2, which is 5, which is not equivalent to 6. If you sum up 2 plus 4, it equals to 6. So what will be the answer? Answer will be the indexes of 2 and 4, which is 1, comma 2. So this is the output. So now let me explain you with the brute force approach. Let me consider the very first example, 2, 7, 11, and 15. Target here is 9. If we compare and if we compare 2 with 7, 11, and 15, if we compare 7 with 11, 15, and 11 with 15, this is not a single pass solution. This is a multi iterative approach. If you add 2 and 7, it is going to give us 9. This is the answer. But in other examples, you will not be getting results in a single pass. So this eventually increases our time complexity to big O of n square, which is not what we are looking for. We are looking for the most optimized solution here. So can we solve this in an optimized way? Yes, we have a solution using a hash map. So let me explain you with the example. 2, 7, consider 2, 7, 11, and 15. Let me just consider the same example with the target 9. I'll just write down the indexes of all the elements. Yes. So 2 has the 0th index, 7 has the first index, 11 has the second index, and 15 has the third index. Let me frame the hash map as the value and the index. So to proceed further, let us calculate a difference with the target value. So let's move on to the very first uh, iterative element, which is 2. So calculating the difference as target minus the number equal to some value exist in our hash map or not. So let's consider 9 minus 2, which is equal to 7. Does it exist in our hash map? No, it does not exist in our hash map. So what we are going to do here is we will be appending the hash map with the value 2 and its index. So let's append the hash map with the value 2 and its index. Moving to the next element, which is at the index first, and the number is 7. Let's calculate the difference. 9 minus 7, which is equivalent to 2. Does 2 exist in our hash map? Yes, it does exist in our hash map. So what we are going to do here is we will be returning the set of indexes. The index involves the index of the value 2, which is 0. This should be in the hash map, and the index of the element of what we were checking for, which is the value 7, and its index is 1. So the answer is 0, 1. If you manually add the elements, 2 plus 7 equals to 9. So this is our answer, and this is the approach. Let's consider the second example, which is 3, 2, 4, and target equals to 6. Let me write down the indexes. Let me write down the elements once. Let's calculate the difference. The very first, let me also frame the hash map once. Value and the index. Let's calculate the very first difference. So 6 minus first element is 3 equals to 3. 3 does not exist in a hash map. Let's append our hash map to the value 3 and its index. Okay. Now moving to the next difference. 6 minus 2 equals to 4. 4 does not exist in our hash map. We will be appending 2 with the index of 1. Moving forward with the third difference, which is 6 minus, what is the element? The element is 4 equals to 2. Now, if you check, 2 has a presence in our hash map. So we will be returning the indices. We will return the index of the 2 in the hash map, which is 1, comma, what was the element we were calculating the difference on, which is 4. And what is the index? Index is 2. So this is the answer. If you manually add up the values of the indexes 1 and 2, what is the first index, which is 2, and what is the second index? 4. 2 plus 4 equals to 6. So this is our answer. So now this is a single pass solution. We did not iterate it multiple times. So time complexity will be O of n, and obviously we are storing each and every elements in our hash map, so we are utilizing the space. So space complexity will also be O of n. So this is the complexity analysis. Now let's move forward with the code. So let me initialize our hash map first. Once initialized, let's iterate in our array. So iteration will happen in the Python like this. For I, comma n in enumerate the set of numbers, which is array. Let's calculate the difference as target minus what we were calculating with, which is n, the numbers. Now we will check if difference exists in our hash map or not. If exists, then we will return the set of indexes, which is first index will be the index which is present in our hash map, which is the map of the difference, comma I. This is the second index. And now if we do not find any indexes, then we will just simply update our hash map with the value I, and then we will simply return. So finally, uh, let's comment this out and let's submit our solution. It perfectly works. So we have successfully solved two sum with the very most optimized solution with a time and space complexity of big of n. So if you liked my video, please like, share, comment, and do subscribe to the channel.